In your formula booklet, you will see the volume of a sphere, the surface area of a sphere, volume of a cone, and curved surface area of a cone. So you don't need to remember these formulae. Here's an example. We want to find the volume of this sphere, give your answer in terms of pi, and then to 2 decimal places. So first of all, the formula for volume of a sphere is 4/3 times pi times the radius of the sphere cubed. Now in this question, the radius is 5 centimeters. That's the distance from the center of the cube, the center of the sphere to the circumference of the sphere. So here I can substitute r for 5. So I can say I have v equals 4/3 times pi times 5 cubed. So v is going to be, right, if we put this into a calculator, that will work out 5 cubes 125 times 4, you have 500. So we end up with 500 pi over 3. And you can put it into a calculator to get your answer to 2 decimal places. And you will get 523.60. And the units are obviously centimeters cubed. In this example, we're expected to work out the volume of a hemisphere. Now, to work out the volume of a hemisphere, you just work out the volume of the full sphere. So if you imagine you had a sphere with diameter 8 centimeters, and then you just divide your answer by 2, because a hemisphere is just half of a sphere. So if I say volume full equals 4/3 times pi times, well, the radius of this sphere is 4, so 4 cubed. If I do that, I'll end up with 256 pi over 3. And if I want the volume of the hemisphere, I just need to divide this by 2. I divide that by 2, I should get 128 pi over 3 centimeters cubed. And I can put it into my calculator. And I get 134.04 centimeters cubed. Here are some questions for you to try. Please pause the video now and have a go. And when you're ready for the answers, press play. Okay, let's go through the answers. For the first one, you've got a sphere of radius 12 centimeters. So the volume is going to be 4/3 times pi times 12 cubed. So that's going to be, if I put that into my calculator, 4/3 times pi times 12 cubed. Right, that gives you 2,304 pi centimeters cubed, which to 2 decimal places is going to be 6,000 something, or 7,238.23. Again, centimeters cubed. For 2, you need to work out the volume of the northern hemisphere of the Earth. So think of it as a hemisphere with radius 6371, or 6.371 times 10 to the 3 kilometers. So what we're going to do first, imagine the full volume of the Earth. We'll do that. So that's going to be 4/3 pi times 6.371 times 10 to the 3 cubed. So let's do that. So So 6.371 times 10 to the 3 cubed. That gives me 1.08 times 10 to the 12, which to one, well, let's just, we'll round at the end. So 1.08 times 10 to the 12 kilometers cubed. But if I only want the northern hemisphere, I divide this by 2. So we divide that by 2 and we get 5.42. Well, to one significant figure, you get 5 times 10 to the 11 kilometers cubed. The volume of a cone is given by 1/3 times pi r squared times the vertical height. Now, r is the radius of the circle that makes up the bottom of the cone. So another way to think about this is that it's 1/3 times the area of the base, because the area of the circle is pi r squared, times the vertical height. That's just another way of thinking about it. So here, the radius is 6. The vertical height is, or the perpendicular height you can say, is 10. So we have the volume equal to 1/3 times pi times 6 squared times 10. Right, now this gives you 180 pi. No, I don't think it does actually. 6 squared is 36. Over 3 is 12, 120 pi, my mistake. So we have 120 pi centimeters cubed. And we can work that out to 2 decimal places, 120 times pi, which is 376.99 centimeters cubed. Here's a question for you to try. So this is a composite shape. A child's toy is made of a cone of radius 14 centimeters on top of a hemisphere of equal radius. Find the volume of the toy to 2dp. Please pause the video now and have a go. And when you're ready for the answer, press play. Okay, let's go through the answer. Firstly, we need to work out what the height of the cone is. Well, we know that the radius of the hemisphere is 14. So to work out the height of the cone, we just need to do 34, which is the height of the entire toy, take away 14, which will give you 20. So the height of the cone is 20 centimeters. So what we can do is firstly work out the height of the cone. So if I say cone, to work out the height of the cone, it's going to be 1/3 times pi times 14 squared. That's going to be the base area, and then we times that by the height. I'm going to leave everything in terms of pi for now. So let's do that. We can put into a calculator. 1/3 times, I'm just going to work out the numerical part first. 1/3 times 14 squared times 20. We get 3920 over 3. So we have 3,920 over 3 pi. That's the volume of the cone. Now let's work out the volume of the full sphere. So if we imagine we had a sphere of radius 14, it would be 4/3 times pi times 14 cubed. So let's work out that volume. Right, that is 10976 pi over 3. And then to work out the volume of the hemisphere, it's just going to be half of this. Which is 5488 pi over 3. So the total volume is going to be 3,920 pi over 3. Plus 5,488 pi over 3. Let's work that out. Okay, and we should get 3136 pi. And we can just press SD and we get 9852.03. So 9,852.03 centimeters cubed. A pyramid is very similar to a cone. It's just that the base is not necessarily a circle. It can be triangle, a rectangle, or a square, or perhaps a different shape, an octagon. And whatever shape you have, the volume of a pyramid is given by 1/3 times the base area times the height. It's exactly the same as a pyramid, only instead of pi r squared we have whatever the base area is. And this formula isn't given to you, so it needs to be remembered. If I want to find the volume of this square base pyramid, I first of all need to work out the base area. Now the base is obviously a square, and to work out the area of a square we do length times width. So that's going to be 8 times 8, which is 64. And to work out the volume I need to do the base area, which is 64, times by the height, which is 6. And let's do that. No, we don't actually, no. To work out the volume, now that we know the base area, I need to do 1/3 times base area of 64 times by 6. 1/3 of 6 is 2, times by 64 is 128. So the volume here will be 128 centimeters cubed. In this question, we're told that the volume of the square base pyramid is 216. Find its height. Well, it's a square base pyramid, and the side of the square is 9. So to work out the volume, we would normally do 1/3 times the base area, which is 9 times 9, 81. And then we would times by the height, but we don't know what that is. So I'm just going to call it h. And that will give us 216. I'm going to calculate 1/3 times 9 times 9 first. 9 times 9 is 81, and if I then divide that by 3, I get 27. So I can say 27 times h equals 216. To get h on its own, I could divide both sides by 27. So h is going to be 216 over 27, which is 8 centimeters. So we can say the height is 8 centimeters. Here are some questions for you to try. Please pause the video now and have a go, and when you're ready for the answers, press play. Okay, let's go to the answers. The volume of the sphere is 500 centimeters cubed. Okay, let's go to the answers. In the first question, we know that the volume of the sphere is 4/3 pi r cubed. And we're also told the volume is 500. So I basically needed to solve this equation for r. What I could do first is multiply both sides by 3. So I have 4 pi r cubed equals 1,500. I could then divide both sides by 4, which will give me pi r cubed equals 1,500 over 4, which is 375. And then what I could do is divide both sides by pi. So r cubed is 375 over pi. The opposite of cube is cube root, so I could now cube root both sides, giving me cube root of 375 over pi. I could put it into my calculator, so we have shift cube root 375 over pi. And we get an answer of 4.92 centimeters. In question 2, we're told the slanted length of the cone is 65. To find the volume of the cone, we need to work out the height. So I'm going to use Pythagoras' theorem. If you look at the cone from the front, you can see a right-angled triangle, or you can see that it's made up from the front of 2 right-angled triangles. The base is going to be half of 16, which is the radius of the cone, which is 8. And we don't know what the height is. So if I do a quick sketch, we should be able to work out what the height is with Pythagoras' theorem. So if I call the height b and 8a and then 65c, we know by Pythagoras' theorem a squared plus b squared equals c squared. 8 squared plus b squared equals 65 squared. To get b squared, we can subtract 8 squared from both sides. So b squared is going to be, if I just get my calculator, we have 65 squared, take away 8 squared, we get 4161. And then to get b on its own, we need to square root both sides. So we have the square root of 4161, which is 64.51. What I can do now is use this in the formula. So the height of the cone is 64.51. So to work out the volume, it's 1/3 times pi times r squared 8 squared times 64.51. And I can just put that in now. So we have 1/3 times pi times 8 squared, 1/3 pi r squared times height. And I get an answer of 4,323.22 centimeters cubed. And the last question, a square-based pyramid has volume 640 and perpendicular height 10. Find the length of one of its base sides. We know it's a square-based pyramid, so that means the base will, of course, be a square. If we look at it like that, we can see the base is obviously a square. Now, we know the formula for the area of the volume of a pyramid is 1/3 times base area times height. And that's going to be the volume. So if I substitute in what I know the volume is 640. So 640 equals 1/3 times base area times by the height of 10. To get the base area on its own, I could multiply both sides by 3, which is going to be 1,920. And then I could divide both sides by 10, giving me 192. So the base area is 192 centimeters squared. So we have a square where the base area is 192. So to work out the area of one of the sides, we could square root 192, which will give you 192, 8√3, or to 2 decimal places, that is 13.86 centimeters.